Hello, this is Mrs. Ward, and I'm going to go over the homework for section 2.1, which is the derivative in the tangent line problem. So the first one, in numbers 1 and 2, they want you to estimate the slope of the graph at the points 1, the first point and second point. So they want the slope. So they drew the lines in there. They drew the tangent lines in there, and they wanted to find the slope. So the first one is just this horizontal line. So I'm going to find the slope of that horizontal line, so that is just going to be 0. The second one, I'm looking here and I'm going to try and find the slope, and I'm going to try and find two places where it crosses through. So here's one, and then here's another one. So it looks like I'm going up 1, 2, 3, 4, 5, 2. So my slope is going to be 5 halves. Okay, doing the next one, I have this point here, x1, y1, and I'm going to look for the best. So let's say here and here. So I'm going down 1, 2, 3, 4, 5, 1, 2. So that looks like it's going to be a negative 5 halves. And then the next one, it looks like maybe here and here. So I'm going up 1, 2, 3, 4, 5. 1, 2. So I have 5 halves. I believe the book has 2, so we're close. Just a ballpark. It is important that you know that it's positive or negative, though. Okay, the next one, find the slope of the tangent line to the graph of the function at the given points. So what they want you to do is they want you to use that slope formula. So I'm going to take the limit as delta x approaches 0 of 3 minus 2, and then in place of x, I'm going to write c plus x, so negative 1 plus delta x minus f of x, which is 5, and this is going to be all over delta x. So when I do this, because I'm finding the slope of the tangent line at this point, I'm going to have 3 plus 2 minus 2 delta x minus 5 all over delta x. And I'm taking the limit as delta x approaches 0. The 3 plus 2 and the negative 5 is equal to 0. Then my delta x's will simplify. And there's no need to substitute in delta x equal to 0 because I'm only left with a negative 2. So the slope of the tangent line of the graph 3 minus 2x at the point negative 1 is going to be negative 2. Okay, doing number 8, I'm doing the same thing. I'm going to take the limit as delta x approaches 0. In place of that x, I'm going to write 2 because that's my c. So I'm going to do 5 minus 2 plus delta x squared minus f of x, which is, or f of c, I should say, which is 1. And this is going to be all over delta x. When I FOIL, I'm going to have 5 minus, and then this will be 4 plus 4 delta x plus delta x squared minus 1 all over delta x. Now I'm going to distribute my negative sign. So I'm going to have 5 minus 4 delta x minus delta x squared minus 1 all over delta x. The negative 4 and negative 1 add up to 5, so those are equal to 0. Factoring out a delta x, 1 delta x. So I should have written delta x times negative 4 minus delta x all over delta x. And I only factored out delta x because I know that's what's going to simplify. Now the delta x is simplifying, and I'm putting in 0 for this delta x. I'm going to have negative 4 minus 0. And my final answer is going to be a negative 4. So the slope of the line 5 minus x squared at the point 2 is going to be a negative 4. And the last one, number 10, I have this t squared plus 2. I'm sorry, t squared plus 3. So this is my c, this is my f of c. So I'm going to take the limit, and in this case it's t approaches 0. So this is going to be negative 2 plus delta x squared plus 3 minus f of c, which is 7, all over delta x. And remember, we're just finding a derivative at one point when we do this. So if I wanted to find the derivative at several points, I'd have to do this over and over again, which isn't very convenient. Here the 4 and 3 are 7, minus 7 is 0. I can factor out delta x from what are, oh, should be delta t. So I'm going to factor out delta t from what's left. So I'm going to take a delta t times negative 4 plus delta t all over delta t. And I'm taking the limit as delta t approaches 0. Delta t simplify, putting in a 0 for this, and I'm going to get negative 4. So the slope of the line t squared plus 3 at the point negative 2, 7, the slope of that tangent line is going to be a negative 4. Okay, now the next one, through 11 through 24, they want me to find the derivative by doing the limit process. This means I'm just going to put in x plus delta x. So I'm still taking the limit as delta x approaches 0 of negative 5 times x plus delta x. That's the f of x minus f of x, f of x, which is negative 5x. I'm just wondering if I should write this formula, and I probably should. I don't know that I'm tall enough. So this is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay, wrote that down. Now I'm good. So now I'm going to distribute my negative 5. And negative 5x minus 5 delta x plus 5x all over delta x. The negative 5x and positive 5x will equal 0. The delta x's will simplify. There's no need to substitute in 0. My final answer is just negative 5. Number 18, I'm going to take the limit as delta x approaches 0 of 1 minus x plus delta x squared minus f of x, which is 1 minus x squared. Make sure you put that in parentheses so you distribute your negative sign. So I'm going to have 1. Can I distribute? And I think I can. Why? I know. This is x squared plus 2x delta x plus delta x squared. And I'm going to distribute my negative sign all in the same step. So this will be minus x squared minus 2x delta x minus delta x squared minus 1 plus x squared, distributing that negative sign all over delta x. The 1 and the negative 1 will equal 0. The negative x squared and the positive x squared will equal 0. These two both have delta x, so I'm going to factor that out. So negative 2x minus delta x all over delta x. I'm taking the limit as delta x approaches 0. The delta x's will simplify, and I'm putting in 0 for this. I'm going to have negative 2x plus 0, and so I'm going to be left with 2x, and that is my derivative. So let's use the derivative notation. So the derivative is negative 2x. Should have done the derivative notation here. Okay, number 24. We need room for 24. So I'm still doing the same thing. So I'm taking the limit as delta x approaches 0 of 4 over the square root of x plus delta x minus 4 over the square root of x, and this is all over delta x. Well, this is one where I have those radicals, so I'm going to have to multiply by the conjugate. But before I do that, I think I want to put them over a common denominator. So let's multiply this by the square root of x plus delta x. And this I'm going to multiply by the square root of x over the square root of x. So I'm going to have 4 times the square root of x minus 4 times the square root of x plus delta x all over the square root of x times the square root of x plus delta x. And I could simplify that, but I'm not going to bother. And then this I'm going to write as times 1 over delta x, taking the limit of this whole thing as delta x approaches 0. To make life easier for myself, I factored out that 4, and I had the square root of x minus the square root of x plus delta x all over the square root of x plus delta x, and then delta x. We'll put everything in parentheses. So that's what I have right now. I'm taking the limit, and if I were to put in 0, I would get 0 over 0. So I know it simplifies. This is what we learned in the first chapter. So I am going to decide to multiply by the conjugate, and I'm only multiplying by this conjugate. This 4 is just going to come along for the ride. So I'm going to take the square root of x plus the square root of x plus delta x, and I'm going to multiply the denominator by that as well. So this, remember, difference of two perfect squares, it's the way I factor it. So it is going to end up being, I don't know why I drew a line there, but I did, 4, and then it's going to be x minus x plus delta x, because I'm going to have to distribute that negative sign. I think I can do that in one step. I think you guys can pick up on that. So this will be minus x minus delta x all over, and then I'm just going to leave this as a square root of x times that's one nasty looking denominator, let me tell you. All right, so the x is in this, x minus x will equal 0. And so I'm going to have this one, this whole thing will end up being minus 4 delta x, and that delta x will simplify without delta x. Once I get rid of this guy, that delta x, that was the whole problem. That's why I couldn't substitute in 0. So now I can substitute in 0. And that's why it's important that I write this limit as delta x approaches 0, because that's why I'm letting the delta x become 0, and that is what it's changing it from a secant line to a tangent line. So this is key. It's pretty important. Write it down. So I'm going to have negative 4 over, that was my soapbox, sorry, square root of x, not substituting anything in, substituting in 0 for here, so that'll also be just the square root of x. That's gone, and then I'm going to have times the square root of x plus, and then this is 0, so this is the square root of x plus the square root of x. So I have this negative 4. The square root of x times the square root of x is just x. And then I have 1 plus 1. So this is times, I don't know how I want to write it, times 2 times the square root of x. And I'm done taking the limit as x approaches 0, so I don't need to write that down anymore. This is the derivative. I could write that. Now I'm going to clean this up a little bit. The 2 and the negative 4 will simplify. And I can leave it like this, and that's perfectly fine. For you overachievers here, you could write as negative 2 over x to the 3/2 power as well. Those are both the same answer. Either one is acceptable. Told you that was a long one. All right, the next one, 25, you are trying to find the equation of the tangent line, and then you're going to use a graphing utility to graph the function and the tangent line, the point, and then you're going to use the derivative feature of the graphing utility to confirm your result. So this is me teaching you how to cheat on your calculator. All right, so the first thing, I'm going to do the work first. So I'm going to take the limit as delta x approaches 0, and I'm going to do x plus delta x squared plus 1 minus f of x all over delta x. I'm going to use this 2, 5 later. I did not forget about that. I'm not making a mistake. Then I am going to do x squared plus 2x delta x plus delta x squared is x squared minus 1. Now these will simplify. Oh, I forgot to write my plus 1. See how I stopped there? Because I knew it had to simplify. I forgot this plus 1. I'm just not making it up. So now that simplifies. Whew, I almost made a mistake. My kid kind of did make a mistake. Factoring out the delta x. So this will be 2x plus delta x. Delta x. These delta x's will simplify. Putting in a 0 for this, I'm going to have 2x plus 0. So 2x, that is my derivative. But remember, it wants the derivative at this point, so this is when x is equal to 2. So I'm going to go down here and say The derivative at 2 is going to be 2 times 2, which will be 4. So that tells me that is the slope of my tangent line. The slope of my tangent line is 4. I wanted to find this, I want to write the equation of the tangent line that goes through this 0.25. So I know a point and I know a slope. I can write a line. That's algebra 1. So I'm going to do point slope, which is y minus y1 is equal to mx minus x1. That's how I'm going to start every single time. I don't do slope intercept. So my point was 2, 5. So I'm going to do y minus 5 is equal to 4 times x minus 2. So I'm going to have y minus 5 is equal to 4x minus 8. And so my tangent line is going to be 4x minus 3. Now this is where we get out the calculator, so give me a second. So the first thing I'm going to do is type in the equation of the function, which is this parabola right here, and then I am going to check the equation of the line that I came up with, which was 4x minus 3. And if I'm having a good day at the 0.25, it should go through and it should look like it's tangent, and it does. That's checking it with the graph. Now to use the derivative function at a point on my calculator, I'm going to open a calculator page. I'm going to do menu, calculus, numerical derivative at a point. I'm going to pick that. The variable I'm using is x. My value of x that I want to find the derivative is 2. I want to find the first derivative. We'll talk about higher order derivatives later. And then I'll see this. This is another notation for derivative. I'm going to type in the function, that x squared plus 1, because that's the function I'm taking the derivative of. See how I put the x is equal to 2 in here for me? The calculator is going to find the derivative, and then once it finds the derivative, it's going to substitute in 2, and I get 4. So that's a quick way to check to make sure that I have my slope correct. Okay, going back and doing the other one, square root of x. I'm not going to check this one on your calculator, but you know how to do it. So when I do this, I'm going to take the limit as delta x approaches 0, and then this is the square root of x plus delta x minus the square root of x all over delta x. I'm going to end up multiplying by the conjugate. Geez, I wish I would have saved room. So this is going to be multiplied by the square root of x plus delta x plus, oh, that's just messy. So I'm going to multiply by the square root of x plus delta x plus the square root of x. And I'm going to multiply both the numerator and the denominator by the same thing. That's with this. So when I multiply the numerator, I am going to have x plus delta x minus x all over delta x times the square root of x plus delta x plus the square root of x. Now the x and the negative x will equal 0. The delta x's will simplify. The limit as delta x approaches 0, I'm going to have 1 over, in place of this, I'm going to write 0, so I'm going to have the square root of x plus the square root of x, so I have 2 of them. So I'm going to have 1 over 2 times the square root of x, and that's going to be my derivative. Now it wants the derivative at the point 1, 1. So now I'm going to find the derivative at 1, and I am going to do 2 times the square root of 1, which will end up being 1/2. That's the first part. That's the derivative. Now it wants to find the equation of the line. So again, point slope, y minus 1 is equal to 1/2 times x minus 1. So this is y minus 1 is equal to 1/2 x minus 1/2. Add 1 to both sides, and I have 1/2 x plus 1/2. You're more than welcome to check a graph the function on your calculator. So graph this on your calculator. Then graph this on your calculator, make sure they intersect, make sure it looks like a tangent line, and then check the derivative using the derivative function on your calculator. Okay, now we're going to get into some problems that are going to be pretty tricky. So this one says the graph of f is given. Select the graph of the derivative. So if I look at 37, this is it's a line, and it has a slope of, it looks like it has a slope of 1. So the slope is always going to be 1. It's looks like it's the equation is y is equal to x if I were to guess what that equation was. So when I go over here, I'm looking for a derivative that's just 1, always 1, and that's going to be b. So 37 is b. Then when I look at 38, what I can tell that 38 is from here to here, my derivative is going to be negative. At 0, it looks like my derivative will be 0. And then from here, my derivative will be positive. So I want a graph that's negative at 0, 0, and then it's positive. And the only graph that does that is D. So this one is going to be D. 39, my graph is always positive. I know that I don't have anything to the left of 0. And so I'm going to hold. I think it's A. I'm pretty sure it's A, but I want to verify that this one is not A. This one is negative. Then I have that sharp term, which means there's no derivative. And then it's positive. So do I have anything that's negative, no derivative, positive? And think about it. This looks like an absolute value. It looks like this slope would probably be -1. Looks like this slope would probably be a +1. And that looks like that's going to be match up with graph C perfectly, which means that by process of elimination, this one has to be D. And that does make sense. No, not D, A. Why did I say D? It's A. Oh my. I'm not editing. Sorry. All right, 41. The tangent line of the graph of g of x at the point 5, 2 passes through the point 9, 0. Okay. Find g of 5. Well, g of 5, they give it to me. That's 2. That's easy. And then I want to find the derivative at 5. So I know that the tangent line goes through 9, 0 and goes to this point 5, 2. So I'm going to find the slope that goes through those 2 points. So I'm going to do, let's say, 2 minus 0 over 5 minus 9. So that's 2 over -4. So -1/2. So my derivative at 5 is just going to be -1/2. So that was a fancy way of asking for the slope of the line that goes through those 2 points. 43, it says sketch the graph of f, explain the derivative of x, explain how you got your answer. So this is where I'm going to look at the graph and I'm going to sort of guesstimate. So here's what I want. So up until 4, it's negative. So here, let's say, so from like -infinity to 4, my slope is negative. Then at 4, it looks like my slope is 0 because it crosses through 0. And then after 4, so from 4 to positive infinity, my slope is a positive number. So I want something that goes down, and at 4 is 0, so I'm going to have some type of vertex. And then after 4 is positive. And I'm going to think of a parabola. That's the first thing that comes to my mind. So the graph is going to go something like this. So from here to here, I'm going down. At here, it'll be 0, then going up. Which, 43. Oh, I'm going to do 44. Can I please do 44? See how my slope is 0? Which means, well, that's the graph in the graph. So the slope of this line is 0. It's a horizontal graph. So when I go to do the derivative, it's just going to be 0. All right, 45. This, 45. This one we're trying to, so here, this is one. Oh, I did it wrong. Oh, son of a gun. Now I have to edit. Oh, man, I hate it when I do that. Okay, just. Okay, 43, it says sketch the graph of f, explain how you got your answer. So when I look at this, it looks like if I go up 4 and run 4. So the slope of this line is 4, which means my derivative, the derivative of f of x, is just going to be 4. No, that's wrong. Let's try that again. So this is the graph of the line, and they want me to sketch the graph of the derivative. So I'm going to try and find the slope of this line. So it looks like I go up 4. So the slope of this line is up 4 over 4. So the slope of this line is 1, which means the derivative is 1. So I'm going to drop a line at 1, and that's going to be the graph of the derivative. Number 44, the slope of this line is 0, which means the derivative is also just going to be a straight line at 0. When I look at 45, I'm going down, so I want a negative slope, and then it's going to hit 0, and then I'm going to go up. So the graph of derivative, I want something that's below 0 until I hit 4. Then I want to be at 0 at 4. So 0 at 4, below 0, and then above 0. So it's just going to be something like that. Okay, 46, this slope from here to here is negative 1. The slope from here to here is positive 1. And at 4, it does not exist. So I am going to do, I'm going to graph it over here. Negative 1. So it's going to be negative 1 until I hit 4. And it's going to be positive 1 after 4. And that's going to be the graph of the derivative. Identify the function that has the following characteristics, then sketch the function. So f of 0 is equal to 2, and then the derivative is equal to negative 3 the entire time. Well, if the derivative is equal to negative 3, that means the slope of my line is negative 2, and they're telling me my y-intercept, are they not, which is 2. So the function is going to be negative 3x plus 2. And that's all I'm going to do for that one. This one, 54, f of 0 is 4. The derivative at 0 is 0. So that's kind of telling me I'm going to have some type of vertex situation going on there. The derivative is negative for values less than 0, positive for values greater than 0. So f of 0. So I'm going to write, since I have, it's going to be something squared, and since f of 0 is 4, I'm going to add 4, and then I'm going to say my function is x squared plus 4. Number 58. You know, your book went through this whole process of finding the slope, but I can, what it wants to find the equation of the two tangent lines of the graph. I can see that it's going through, it looks like that's going to be negative 1, 1, because it's x squared. So then if I want to find the slope of the tangent line, I'm going to say 1 minus negative 3 over negative 1 minus 1. So this will be 4 over negative 2, and I get a slope of negative 2. And find the equation of the two tangent lines. So now I need to write an equation of the line. So I know the slope is negative 2. I can pick either one of these points, and I believe I chose that point. So I'm going to do y minus negative 3. So y plus 3 is equal to negative 2x minus 1. So I'm going to have y plus 3 is equal to negative 2x plus 2. Subtract 3. We have negative 2x minus 1. Then the second line, it is this point here. Well, I guess at that point is 3, and then 3 is 9. So I'm going to find the slope between those two. So I'm going to say 9 minus the negative 3 over 3 minus 1. That's 12 over 2, which is 6. So now I'm going to do y plus 3 is equal to 6 times x minus 1. Subtract 3 from both sides. I'm going to have 6x minus 12. Minus 12, nope, close. When I take minus 3, that's going to be y is equal to 6x minus 9. So that is going to be my final answer. derivatives, you're going to take the limit as x approaches the c value, and you're going to do f of x minus f of c all over x minus c. So for 71, I'm going to do x squared minus 1, and then when I put in 2, that's 4 minus 1, which is 3, all over x minus 2, and I'm taking the limit as x approaches 2. So this will be x squared minus 4 over x minus 2. And then this cofactor is x plus 2, x minus 2, all over x minus 2. Those will simplify. I'm still taking the limit as x approaches 2. So then I'm left with x plus 2, and I'm taking this limit as x approaches 2. So I'm going to have 2 plus 2, and that is going to be 4. Okay, number 77, using that same formula, or I'm sorry, yeah, 77. So I'm going to do 77. I'm going to do x minus 6 to the 2/3 minus, and I'm putting in 6 here, so 6 minus 6 is 0. 0 raised to any power is going to be 0, all over x minus 6, and I'm taking the limit of this as x, just x, as x approaches 6. So this is going to be x minus 6 to the 2/3 power over x minus 6. And remember, that's understood to be the first power. I said 6. And then when I do these, I'm going to end up having 1 over x minus 6 to the 1/3 power. Remember, you subtract exponents. So when I go to substitute in 6, nothing simplifies. So I'm going to have 1 over 0 to the 1/3 power, which is not possible, which means that this limit does not exist. I cannot find this limit. I cannot find a derivative at that point. Okay, 79 is that absolute value of x plus 5 at 5. So 79, I'm going to take the limit as x approaches -5 of x plus 5 minus, and when I put in -5 into that, that'll be 0, just making sure, over x minus 5. So this is one of those cases where I have that absolute value, and I'm taking the limit as x approaches -5. Well, to help me do that, you realize from one direction it's -1, from the other direction it's +1. So since it's not approaching the same number, it does not exist. I cannot find the derivative. This is one of those examples of a sharp turn. So I cannot find the derivative there. Okay, and finally the last one. It says describe the x values at which f is differentiable. The only problem I'm going to have finding, oh, this is not the last one. The only problem I'm going to have finding a derivative is at these sharp turns, which look like happen at 3 and -3. So there's 2 ways that I can do it. I wrote the -infinity to -3 union -3 to 3 union 3 to infinity, because it's asking me when can I find the derivative. The book said x, you can find the derivative except when x is equal to plus or minus 3. They're both saying the same thing. It's just a matter of how you want to write it. Okay, number 95 and 96, it says determine whether the function is differentiable at x is equal to 2. So the first thing I'm going to do is, because it's a piecewise function, I'm going to check and see if it's continuous. So if I put in 2 squared plus 1, that'll be 5. 4 times 2 minus 3, that is also 5. So this tells me that it's continuous. Then what I'm going to do is I'm going to find the derivative using the alternate form. So I'm going to go as x approaches 2, but I'm going to approach from the left, which means I'm using this top formula. And I'm going to do that x squared plus 1. And when I put in 2, we just said that was 5 over x minus 2. The formula, the alternate we just did. So this is going to be x squared minus 4 over x minus 2. And I'm doing this from the left because that's the formula I'm using. So this will be x plus 2, x minus 2, all over x minus 2. So here, I'm putting in 2, and this is just telling me that I'm coming from the left. I'm going to have 2 plus 2, and I'm going to get 4. So my limit, so my derivative, well, I'm not going to say derivative because it might not be my derivative. So I'm saying this limit as x approaches 2 from the left is 4. Okay, now I'm going to do the same thing except for I'm going to do from the right. And I can do that. I can do that. So the limit as x approaches 2 from the right, which means now I'm using this formula here. So I'm going to do 4x minus 3 minus f of c, which we just said was 5, over x minus 2. It's still the same work. It's just that you're using one from the left, one from the right. You're using the 2 different formulas. This will end up being 4x minus 8. So I can factor out a 4 and make it x minus 2. X minus 2. The x minus 2's will simplify. And then I'm going to end up with 4 because there's nowhere to substitute in the 2. So since these two are the same, that means I can find the derivative, and the derivative of this function at 2, specifically at 2, the derivative of this function at 2 will be 4. Good? All right, let's do 95. I said 95, I'm in 96. First thing I'm going to do is check for continuous. I'm going to do 1/2 times 2 plus 1. So there'll be 1 plus 1, and that's 2. The square root of 2 times 2, square root of 4, which is also 2. So it is continuous. And I have to do that work anyhow, so it's not doing extra work because you're going to have to find out what f of c is in both cases. So now I want to find the limit as x approaches 2 from the left, which means I'm using this formula here. So I'm going to do 1/2 x plus 1 minus 2, because that's what f of c is, all over x minus 2. So this ends up being 1/2 x minus 1 over x minus 2. So I thought of this, I thought, well, if I multiply this by 2, that's, I don't know if you have to think this hard, but we'll think this hard for you. So if I multiply this whole thing by 2, I'm going to have x minus 2. If I multiply the numerator by 2, I have to multiply the denominator by 2. Now these x minus 2's will simplify, and I'm left with the limit as x approaches 2 from the left of just being 1/2. Now I'm going to find the limit from the right. So the limit as x approaches 2 from the right, which means I'm following this formula, the square root of 2 times x minus 2 all over x minus 2. I am going to have to multiply by the conjugate. So the square root of 2x plus 2, square root of 2x plus 2. This will end up being 2x minus 4 over x minus 2 times the square root of 2x plus 2. Still taking the limit as x approaches 2 from the right. Factoring out a 2. So here are the x minus 2's will simplify. Now I can substitute in this 2. So I'm going to have 2 over the square root of 2 times 2 plus 2. And so that'll end up being 2 over the square root of 4, which is 2. So 2 over 4, which is 1/2. Again, since these are the same, then your derivative at 2 is 1/2. If they were different, then you would say it's not differentiable at that point. All right, I hope this helps, and we'll see you next time.